A Telebyte video.
Welcome to a demonstration of IEEE 802.3 CG 10BASE-T1L compliance testing using 2.4 volts peak-to-peak and test mode 1. This demonstration will feature analog devices evaluation board and Ethernet PHY evaluation software with Telebyte's digital analyzer, probe, and software. This demonstration will show you how to identify problems, analyze transmit signal output voltage and timing jitter, perform repeatable testing, see clear pass-fail results, and produce printed reports with graphs. The equipment and software in this demonstration includes analog devices eval ADIN 1110EBZ EVM evaluation board, analog devices Ethernet PHY evaluation software, Telebyte's 4975 digital analyzer and software, as well as Telebyte's 4975 P01 probe for signal capture. This setup can test with 1.0 volts peak-to-peak and 2.4 volts peak-to-peak. It can also test with test modes 1, 2, or 3. Let's take a look at the devices and software we'll be working with today. In the bottom left-hand corner, we have our analog devices evaluation board. This board receives its control and power via a USB connection that goes to the Telebyte 4975 digital analyzer, which is loaded with Telebyte's 500 software, as well as analog devices Ethernet PHY evaluation software. The evaluation board is also connected to the Telebyte 4975 P01 probe via an adapter cable from a 3-terminal SPE screw connector to an RJ45 connector. The probe also has a 100 ohm termination on the front, and from the back it is connected to the digital capture card that is installed in the digital analyzer. In order to enable USB power on the ADI evaluation board, do the following. At P5, connect a USB cable. At P4, jumper pins 3 and 4. Next, we need to connect the probe to the 4975 digitizer card. This is done by using an SMA to SMB cable, which is connected to the digitizer card and also to the back of the 4975 P01 probe. Then we need to set the attenuation to 0 dB. This is accomplished by manually sliding the red switch on the probe to 0 dB. Let's take a look at the software in action.
Today we're going to test the 10BASE-T1L transmitter compliance testing in the IEEE 802.3 CG-2019 standard. I have an analog devices evaluation board, the 10BASE-T1L MAC PHY. It's the eval-ADIN 1110 EBZ model. And I have the Termite software. It's a serial connection using the USB connection on the evaluation board using a COM port COM13 with 115,200 bits per second, 8 and 1 parity with no handshaking. And then I have the Telebyte 500 series signal analysis software. So you can see right now the board is in a 2.4 volt state. I'm going to issue these commands to send this and put the device into test mode 1. So we're going to use the PHY write and the PHY read commands to write to the registers of the ADIN PHY. You can see we disable auto negotiation. We go into a software power down mode. We enable a force mode, and then we'll write 2000 to this register 0108F8. That puts the transmitter into a test mode 1 pattern. so that we can do our jitter analysis and our transmitter output voltage level testing in the device up. So all these commands have gone through okay. So I'm done talking to the device. I can come to the Telebyte 500 series software and open up the spectrum analyzer. So you see I am on channel 1 here, and I'm seeing this is the frequency domain signal, where I have frequency on the x-axis out to 25 megahertz, 2.5 times 10 to the 7th. And I'm looking at the y-axis here, the power spectral density in dBm per hertz. So this is the +1 and the -1 signal in the frequency domain. So now what we want to do is run a capture. You see I have the ADIN 1110 test mode 1 2.4 volt signal. I'm going to start a capture at 500 million samples a second and capture for 2 seconds. And I'm using channel 1. It's on with AC coupling and 100 ohm load impedance with the 2.5 volt digitizer range and 0 dB setting. So I'll hit start here. We'll overwrite the file. So here I see my ones and negative ones. I can analyze the spectrogram view. It shows you about a 20 megahertz bandwidth on the bottom. The green is a higher power than the blue. And then we can do a signal analysis here. I can analyze the signal between the red cursors here. And this will show a time domain view in the left corner here. And it shows a signal with about a positive 1.2 volt and a negative 1.2 volt peak. So that's the 2.4 volt peak to peak operating mode. Then I see my frequency domain view. We do an FFT on the time domain signal and show the frequency domain. And then we have our amplitude probability density function here. So I'm going to zoom in on the time domain view here. By drawing a rectangle around the signal, you can see it looks like what we're expecting for a test mode 1 signal, +1 followed by a -1. So you can see the signal level here. But what we want to do in test mode then is see what these transmitter output voltage level values are, as well as look at jitter and the clock frequency. So you have a jitter analysis package here that will do an analysis on this time domain signal. So we'll hit jitter analysis channel 1. And this will produce an eye diagram with the values that we want to look at in test mode 1. So here we see the signal and we see our parameters for the eye diagram. So an open eye means that we're going to get very good error-free data transmission. So you see the amplitude of the eye is 2.287 volts. The height of the eye is 2.285 volts. And the width of the eye in time is 130.5 nanoseconds. Then we have the SNR is 67.9 dB. So an SNR value is good. The rise and fall times, 32.4 and 32.3. It does look like a fairly symmetric eye here. The clock frequency is 7.499891 megahertz. And then the jitter peak to peak value is 2 nanoseconds, what we're measuring. And then the RMS value of the jitter is 0.9 nanoseconds. So the peak to peak jitter must be less than 10 nanoseconds in order to pass. So we're passing by a fair amount here of room. So Analog Devices has done a good job on this. We do want to run a test report, so we'll go over to the test report window here. And you can see we do the 802.3cg compliance testing as well as the Ethernet advanced physical layer. I'm going to test Analog Devices here. The model is the eval EDIN 1110I, and we're in a 2.4 volt operating mode. So what I'm going to do is load this capture file that we've stored for 2 seconds, the test mode 1 2.4 volt peak to peak signal, and we will generate the report. This will open up a PDF report of the jitter in the 2.4 volt operating mode. So here we have the PDF file with the automatically generated report. We have a table of contents here. And then we get the test information, our software version, our digitizer serial number, the manufacturing and model name. Then in the transmitter output voltage in test mode 1 for the 2.4 volt peak to peak mode, we should have a minimum voltage of 2.04 volts and a maximum of 2.52 volts. So we're measuring 2.296. So that is a passing test result. It's within the range of what it should be. And then we come over, scrolling down, we get to the transmitter timing jitter. So for the 2.4 volt mode, you saw the limit is 10 nanoseconds, and we measured 2 nanoseconds, so that's a passing result. Then we see a histogram here of the clock. So the clock period is 133.3 nanoseconds, and with a 500 million sample rate, you're measuring 132 and 134. So we're seeing the histogram of the values measured. And that is the results here. Also the clock frequency. So we should be for the 2.4 volt mode, it's really the same for the 1 volt and the 2.4 volt mode. We should have 7.499625 megahertz to 7.500375 megahertz, and we're measuring 7.499884, which is a pass. And over a 2-second short-term variation measurement, we should have less than 0.1 part per million variation, and we're seeing 0. So we're less than the maximum variation, so that's a pass as well. So Analog Devices has done a very good job in terms of controlling their timing jitter, their transmitter output voltage level, and the short-term variation in the 2.4 volt operating mode.
Thank you for watching this demonstration today. Here are other videos that you'll find in this series.
We would be happy to provide you with more information. Please go to telebyte-SPE.com to learn more, or you can send an email using sales@telebyte-SPE.com.